So, welcome to everybody to the second keynote today. And my name is Mike Arnold. I'm the Vice President for Research, Innovation and Transfer at the University of Applied Sciences in Dresden. And it's a great pleasure to introduce you to our second keynote speaker, Professor Dr. Jan Plass. And he is a Paulette Goddard Chair in Digital Media and Learning Sciences and a professor at the New York University. He is the founding director of the CREATE Consortium for Research and Evaluation of Advanced Technologies in Education and co-director of the Games for Learning for the Learning Institute. In his research, he focuses on a broad range of fields, including cognitive sciences, learning sciences, computer science, and the design of games and different learning environments. His research group is investigating cognitive, social, and emotional design patterns for the development of effective games, simulations, augmented and virtual reality scenarios. He has authored and co-authored over 120 journal articles, chapters, and conference proceedings, and he is a lead editor of the Cognitive Law Theory in Cambridge University Press. And recently, in 2020, he published a book, The Handbook of Game-Based Learning at MIT Press. He has also published a wide range of international and well-known journals about topics such as the taxonomy of adaptability for learning, the effects of executive functions on reading comprehension, emotions in cognitive load theory, and so on and so on. He received his MA in mathematics and physics education and his PhD in educational technologies from the University of Erfurt. Actually, there's a lot more to say, but now it's time to give the floor to Jan Plass and the keynote, which is titled 5 Designs to Make Games More Effective for Learning. Last but not least, after the keynote, there will be a Q&A session. And if you have any question, please write a chat message directly to the organizer Bettina in Gathertown. Thank you. And now it's my pleasure to give the floor to Professor Jan Plass.
Thank you, Mike, for this kind invitation. And thank you to the organizers for inviting me to this conference to give a presentation. And I'm especially delighted since I didn't only get my degree in Erfurt in Germany, but I spent a number of very fun and informative years in Dresden at the Technical University in the Informatikzentrum as part of my studies. So it's a fun situation to be back, even only virtually. So let me share my screen. And as Mike already mentioned, my talk today is about how to make games more effective for learning. And I want to focus on some research results that we have shown where there are different design elements of games that can be used to get more effective games. And this has been part of my research at CREATE and the Games for Learning Institute. So I'd like to briefly talk about a model for the design of playful learning on which our research is based, and then talk about learning mechanics, assessment mechanics, emotional design, adaptivity, and level design. And as you can imagine, in 20 minutes, we can only scratch the surface, but I wanted to give you kind of a survey of what kind of research we have conducted and others have conducted in this area. And the focus is to actually translate that into practical applications. So when we think about playful learning, and by that we broadly mean the use of game design elements to support the learning process, where it doesn't necessarily have to be a full-blown game, but it can be. What we're really doing is we're designing different types of engagement, and that's what we believe games are especially good for. And those types of engagement, of course, are the cognitive engagement of processing the information cognitively. But we also have physical engagement. Imagine a Kinect game or any other game where you have to move. We have social cultural engagement. And of course, we have affective engagement. And so what is really interesting to us is to think about how each of these different types of engagements can be used to achieve the learning outcomes that any particular game intends to have. And what we can do here is we have different game design elements that support the engagement and the design for engagement in these different elements. So we have the knowledge and skills that go into the game, the incentive systems, the learning mechanics, assessment mechanics, aesthetic design, narrative, musical score. And I saw in the program, unfortunately, because of the time difference, I wasn't able to attend earlier talks, but I saw that there were already presentations about the narrative and about emotional design earlier today. So you've already had talks about those. What's interesting is that all of these design elements can be supported by theoretical foundations. And here we have, when it comes to affect, a number of different theories that can support that. The same thing for motivation, for cognition, and for social cultural work, learning. And so what our mission is in the Create Lab is to add to these theoretical foundations, to look at different design elements, see what kind of engagement and what kind of learning outcomes they produce. And that's the background for the research studies that I will be presenting very briefly. So we also have used this model and these outcomes for a project where we helped Syrian refugee children in Turkey. We had a month-long intervention to teach language proficiency, mental health, cognitive skills, and coding. And we used the same design framework that I just showed you for some of our games, such as All You Can Eat Tea, that I'll talk about more. Minecraft, we had Cerigo, which is a learning engine, and on the right, code.org to learn about coding. And that was all put together in a 4-week curriculum, and we found positive outcomes on each of these indicators of the outcomes that we intended. The features that I want to talk about already briefly mentioned, so let's get right started with learning mechanics. And the takeaway message for learning mechanics, as far as I'm concerned, is that it needs to be aligned with the learning objective of the game. And what that could look like is, first of all, what is a learning mechanic? In our definition, there are game mechanics, obviously, that we usually talk about. We like to break them down into game mechanics, break them down into learning mechanics versus assessment mechanics. And why is that? The definition would be that a game mechanic or a learning mechanic is an essential moment-to-moment learning activity of players. But the important thing is that it's based on learning theory. And what we do is we create patterns of repeated behavior that become the experiential building blocks of play. So that's modeled after definitions of game mechanics and here applied to learning. And you see in this picture at the New York Hall of Science, we were part of an exhibit. This is Connect-based, where learners can interact with those large screens. And the mechanics here are very much tailored to support the learning process. What we see in this picture here is a geometry game where on the top right is your imprisoned comrade and you're on the top left, and you need to traverse these lattices to make it from one corner to the other, and there are obstacles in the way, but you have to unlock these angles. And what we're learning here is about angles and quadrilaterals. And so in order to align the learning mechanics with the learning objectives, the goal really is to understand the rules that I need to apply: supplementary angle rule, complementary angle rule, etc. So what the learner then should do is select amongst different rules, and you see that in the bottom of the screen. And that would be a learning mechanic aligned with the goal. We compared that to a learning mechanic where instead of the different rules that you need to indicate, that you use to solve the problem, you just tell us what the degree angle is to solve the problem, right? So if I take one angle where the given angle is 70 degrees, then I know the remaining angle that I need to solve for is 110 degrees, and I would just click on 110. So we compared two different games with those two different mechanics, one with the rules and one with the numeric response. And what we found is that indeed the learners in the rule condition performed better in the game than those in the number condition. In other words, when the focus of the mechanic was on the rules, which was also what was tested, then the outcomes were better. And you see the reference here if you're interested. Similarly, we compared 3 different mechanics of the same game. This is a game about factoring. So the question is, in the center, you see in the red circle, a number, and that is your current number. And then you see in the opening of this circle, you see a number that's your target number. And so how do I get from the current number to the target number using different arithmetic functions? And here again, we compared a single player mode on the left, a collaborative mode in the middle, and a competitive mode on the right to see if there were learning differences. And what we actually found is that the best performance in-game and post-game was in the competitive mode for this particular game, which is about rote learning of factoring. And solo play was less interesting than competitive or collaborative play. So playing with someone or against someone was more interesting than playing by yourself. That's not a surprise, but it was a rare occasion where we could actually have one game that would incorporate all three mechanics and where that could be implemented this way. So that's a brief venture into learning mechanics. In contrast, assessment mechanics should be designed to enable high quality measurement of learning outcomes. So if we think that we can use a game to assess outcomes, we need to think about different mechanics, because now our goal is to have essential moment-to-moment assessment related activities. So if I want to measure something, then I may design very differently than if I want to teach something. So here we create patterns of repeated behavior that become the experiential building blocks of play for assessment. And now we need to think about test theoretical considerations. Unfortunately, I don't have much more time to get into that, but when we think about our game designs, we very clearly think about, is this a learning moment and I'm using learning mechanics? Or is this an assessment moment and I'm using assessment mechanics? And I might decide, if the goal is assessment, that I may need to build a mechanic in a way that it elicits the steps of the thinking process and the steps of the problem solving process in different ways than I would, and to make it more explicit so I can see them in my log files, that in different ways than I would if it were a learning mechanic. Emotional design is our third design factor. And for emotional design, the goal is to enhance states that induce emotional designs that induce emotional states that enhance learning. So the background for that is that we found, if we define emotional design as the use of design features with the goal to induce those emotions that enhance learning, you've seen that in many games. Here are some examples. Clearly, games are very capable of inducing those emotions. And what our research focuses on is the affective quality of learning materials, which means their ability to cause change in core affect, in the experienced emotions of the learner. And our research has focused on design features such as the shapes and colors of design elements. And here's a number of research studies that have shown that round shapes and warm colors positive affect emotions in comparison to square shapes and neutral colors. And there are a number of replication studies of this effect, both with by a number of different authors. And you see a game here on the right that we designed to help clinicians to deal with children and in therapy. But the emotional design effect has been replicated and has been established in general, not just in the context of games. What we did in our research is we compared a game where we built two different versions. One version we call the hot EF version, and the other one is the cool EF version. And you see here on the screen our game that we designed that's called All You Can ET. If you're interested, that's available in the App Store and Google Play for free. It trains cognitive skills and has been shown to be effective in cognitive skills training, especially executive functions. And the purpose of this game, or the mechanic of the game, is that these aliens are very hungry, but they change their minds all the time about whether they want the cupcakes on the left or the milkshakes on the right. And I, as a player, have to decide what is the rule that is currently applying and what kind of food or drink do these aliens want. And the rules change, as I said, all the time. They get more complex. And that enhances the executive function's sub-skill of shifting, of cognitive flexibility. You see that on the left, we use round characters and warm, round aliens and warm colors. And on the right, we have neutral colors and square aliens, which is the cool version. And so what we did here is we compared those two with pre-post design, where the only difference was what those aliens looked like. And we found indeed that the hot version resulted in higher executive functions as measured by a dimensional card sorting task, which is a test outside of the game. The hot EF version had higher outcomes, especially for older students, and for which is we did research in middle school and high school. So the high school students did better here in particular, and learners who had low executive functions to begin with. So for those, the hot EF version was more effective than the cool EF version. So an example of emotional design in a game. Emotional design can be induced with many other ways. Here are some design factors: the visual design, the interaction design, the narrative that you already heard about in previous talks, the playfulness, the sound, and the incentives. And so there's many different ways that still need to be investigated on how to do emotional design in games and in other learning materials. A additional design feature is adaptivity. And adaptivity is, of course, personalization is a hot topic these days. And what my argument here is that we need to consider a broad range of variables that we should adapt for. And those could be cognitive, affective, motivational, or sociocultural, rather than what often happens just to adapt for learning progressions in individual steps. So we define adaptivity as the ability of the learning system to diagnose a range of learner variables and then to accommodate a learner's specific needs by making appropriate adjustments to the learning experience with the goal of enhancing learning outcomes. So that's from a recent article. On the right, you see another executive functions training game, which is called Crustaceans. And here, this is about working memory, and you have to, it's essentially in the form of an N-back task. You have to remember what those crustaceans were, what shapes and what colors they were. When it comes to adaptivity design, we need to resolve which variables we should actually adapt for in the system and how these variables can be reliably measured. And then we need to figure out what kind of adaptations can even be made during the learning process to reflect those. And so this is implemented here where we compared an adaptive versus non-adaptive version of our EF game. In the adaptive version, the faster or slower pace of the aliens that were coming down that you needed. So the aliens are coming from the top of the screen, they're coming down to the bottom, and you need to feed them before they hit the ground. In the adaptive version, we had a faster or slower pace based on user performance. In the non-adaptive version, we had the same speed on the different levels for every player. And what we found again here is that the adaptive adjustment of task demand and difficulty resulted in improved outcomes compared to task demands that were adjusted the same for all learners. And just is to remember that in this particular game, repeatedly practicing this skill is one of the key mechanics to train executive functions. So making that adaptive and making it when you do very well, making it harder for you, and when you don't do so well, making it easier for you, did in fact have the outcomes that we were hoping for. We designed based on that a taxonomy of adaptivity where we have an adaptivity cycle. This is not coming up the way it's supposed to, where we're having an adaptivity cycle where from the learner performance, we decide on what variables to use for our assessment. And here you see what I started out in this subsection, that we can pick affective variables. We could pick the learner's emotions. Cognitive variables, we could pick their level of comprehension or understanding of a subject matter. Motivational variables, we could measure how motivated they are for a particular subject matter. Or sociocultural variables, we could see whether the learners have a certain sense of belonging or a need for social interactions, etc., and then respond to that. And then the responses can be many different types of responses in the game. The core learning activity could be adapted for the scaffolds, for the feedback, the guidance, the rehearsal schedule, interaction types, the type of information representation, and what we did, the difficulty progression, but also the conceptual progression. And I'll talk about that in just a moment when we talk about level design. So the final item on our game design feature list is level design. And the level design, we believe, needs to be based on a clear understanding of your target audience. And an example for that is, first of all, what is level design? Clearly, it involves decisions about conceptual and difficulty progressions from one level to the next. This is from one of our other games called Guacamole, where you train the subskill, executive function subskill of inhibitory control. And so in this game, and here's another level where we use, so for the first one, it was about the progression as far as difficulty is concerned. Here's an example for a game to learn about artificial intelligence that we designed together with Filament Games. Here, the level design reflects the structure of the learning content, in other words, the conceptual progression. So what we did in the Guacamole game, Here you see avocados popping up, and the learner needs to decide whether to smash those avocados. Those with the spiky helmets shouldn't be smashed. Those without a helmet can be smashed and have to be smashed. So it's kind of a whack-a-mole adaptation to train executive functions. What we did here is we designed the levels in a way that in one version, the focus was on speed. In other words, the increasing levels would result in increasing speed of the appearance and disappearance of those avocados. Another version, we focused on accuracy. So the learner needed to be, let's say, at an 80 or 90% accuracy of making the right decisions of whether to smash the avocado or not before they could advance. And so we compared for adolescents whether the speed level, where we did the speed level design by speed, where the levels primarily got faster and accuracy wasn't as important, versus accuracy. And what was interesting is that in terms of understanding your audience, early adolescents are primed for speed improvements because they're going through myelination in the brain. Versus mid-adolescents, they're primed for accuracy improvements because they're going through synaptic pruning. And so this is exactly what we found. Early adolescents did better in the speed condition when the focus was on increased speeds across different level designs, versus mid-adolescents did better when we did accuracy as a focus. So again, in terms of mechanics, in terms of level design, understanding our audience and their, in this case, cognitive development has helped design a better level structure for them. So in conclusion, there are many different game design factors that can be used to enhance learning outcomes. You may have noticed that I completely omitted the incentive structure of a game. And I did that on purpose because that's what many articles and talks are about, how to put incentives into games. So I thought I would focus on some others, which were learning mechanics, assessment mechanics, emotional design, adaptivity design, and level design. And I apologize for going through them so quickly, but I hope I gave you an overview of what some of the research looks like. And I'm clearly wasn't able to present all of the research systematically in each of those areas, but it becomes clear that the specific for all of these designs should be based on a theoretical model, such as the playful learning design model or another model to support our design decisions. Many of the articles that I mentioned are available in the Handbook of Game-Based Learning that was already mentioned before, so shameless plug for that one here. And I want to thank you for your attention.
Yes, Professor Plass, thank you so much for this inspiring lecture today, the keynote today, and especially for the 5 elements, which could be understood as screws, how to organize the games and make games more effective. And now it's time for the audience. If you have any questions, so please write a chat message to directly in Gathertown to the organizer Bettina, and we will collect them and then being able to hand it over to Jan Blas. Okay, then maybe I can start with the first question in order to wait for the responses. I would be curious about, is it possible to measure relationships between players and maybe also the players and teachers or instructors in the game? Is this possible? And how, maybe did you came across this question? Because from an educational background, it would be interesting to know, and we know from teaching research that most of the meta studies which measure the effectiveness of teaching already explained that the teacher is so important, and that here in this case also in the game maybe instructors and certain key players would be important. Did you came across such a question?
That's an interesting question. So you're referring to multiplayer games, there are studies that look at games and how people interact within the games and what relationships established. Constance Steinkrüger has done some work in this area, especially when it comes to MMOs. And there are incredibly interesting relationship questions that can be asked. How do people form into tribes or groups within the game? What functions are facilitated by the game or emerge as part of the gameplay? And what's interesting about it is that the strong teacher effects that we see can be replaced by peer effects, right? So it doesn't necessarily have to be a teacher who becomes this very influential person. It could be a peer who assumes a certain role, and it could even be that those roles are rotating. So that's a clearly very complex, but also very interesting line of inquiry in games that are multiplayer games. When it comes to games that don't have strong multiplayer functionality, we still see social components, and they often happen outside of the game, where in forums, on Discord, or in other on Twitch, where players interact, and then the gameplay itself becomes the object of the interactions and of the exchanges. And there's a lot of work that has been done in that area. Maybe a last point to that is the strong teacher effects that we see are not necessarily a positive when we think about equity, right? Strong teacher effects means that good teachers have a strong effect, but it also is very clear that not every region, not every city, not every school is able to have those good teachers for a number of reasons that as a society we haven't been able to address. So games in some ways can become the equalizer for that and can provide an alternative where we have more access to those influential people in our life that help us learn. And so in some sense, that's one of the positive outcomes of games.
Thank you very much for your response. And I have a question from the audience, and I'll read it out loud. What are the most negative side effects during game-based learning, and how can we deal with it? The negative side effects and how to deal with it.
That's a really interesting question. So side effect is actually an interesting word, right? A side effect is an effect, right? We just call it a side effect because we didn't mean to have that effect, but it's still there. So let's just say that is because, well, certainly we are designers of games. If we design a game and it has a certain effect, when we notice that there is an unintended and undesired effect, then we realize we failed as game designers, right? So there are a lot of effects that we may not like for entertainment games. But if a learning game-based learning kind of situation has those effects, then we as designers have to go back to the drawing board. So what could some of those effects be? One of them that I see all the time is when, for instance, the learning mechanic was not aligned with the learning outcomes. My favorite example is the car race game where you race your car, that's the mechanic. Then the car runs out of fuel and you need to solve an algebra problem. So I have algebra as my learning goal, but I have a car race mechanic as my mechanic, and those are completely separated. And there are a lot of games, I don't want to name names or point fingers, but there are a lot of games that do that. And so the side effect here is that people really want to play a game, but you interrupt them with learning, and then you get potentially negative attitudes about the learning content, versus designing a bona fide game where the whatever the outcome was, the goal was, is built into the mechanics to make it interesting. Now, it's not necessarily easy to build an interesting arithmetic or algebra game, but it's still doable. And so because we are the designers of learning games, my argument is if we have those negative effects, we need to deal with them, and we need to revise and design a better game. And being overly focused on the game and not on the learning would be one of those effects that I see most often. And that means that it was over-designed as far as gaming is concerned, and the learning content wasn't paid enough attention to. Which is why we often talk about playful learning rather than game-based learning, right? So if you notice that that's the case, maybe it would be a better approach to make your learning more playful, add some elements that make that playful, a little bit emotional design, and interesting mechanic, interesting feedback, rather than building a full-blown game.
Thank you. And there's another question that came to my back channel. Especially, it refers to the adaptability, which was one of the elements to create and for the game design. And the question is, could you please say more about the kinds of learning effects, especially with regard to adaptive design, And yeah, are there any effects in this field?
Right. So there, we did a whole review article on that. There is one in the handbook, and then we did a separate one that's not just about games. So there's a broad range of research studies on adaptivity. And interestingly, it is not as clear-cut as one would think. If we define adaptivity as measuring important variables during the learning process and then responding to that by giving the learner exactly what they need, one would think that the outcome should be better learning, and the result is not necessarily that. There's mixed results. I haven't seen studies where the effect was negative, but often there are null effects with adaptivity. And there are a number of different reasons for that. And one interesting one, and I don't know if that was by accident or on purpose, the questions actually didn't say adaptivity, it said adaptability. And adaptability and adaptivity, as far as we are defining them, are different. And when we adapt, we need to decide who does the adapting. And adaptivity often assumes the system diagnoses and adapts for you and decides what the next step should be, what material should be presented and how, etc. And here we take agency away from the learner, and we reduce the need for self-regulated learning during the learning process, because now the system does all these steps for me. It's like helicopter parenting with your children, right? You need to put them in situations of making those decisions. And adaptability, in contrast, I would give you smart choices. So the system diagnoses and then proposes a number of choices, but the learner still has to regulate. The learner still has to decide which path to go, which level of problem to choose, which difficulty to choose, etc. And we actually did the comparison study. The results are, again, mixed, as they often are, which means we didn't design well enough, right? So outcomes from many studies on adaptability and adaptivity are positive, but there's still enough that are mixed to make us realize that we need to do a better job designing adaptive systems. And that's why a theoretical approach is so necessary for that, because many adaptive systems, when you ask the designers what they base the adaptation on, you don't get a theory-based response. You get a response that often doesn't satisfy. And so to me, that is the place where we should start thinking about the theoretical foundations for adaptivity.
Thank you so much for responding to the adaptivity question. And there are, I think, a few more questions, but due to time restrictions, we will end this session now. And if you are able to stay a few minutes in the presenters lounge, which we created in the Gamification, so there would be a possibility for all others from the audience to raise your question and talk to Professor Plass. And yes, and as we are at the end of this talk, we would like to say and give a little thank you, and thank you so much for the presentation today, for the insightful ideas, and I think your impulses will last also beyond this conference. And thank you so much for also responding to all the questions after your talk. And we prepared a little present for you with some specialities from the region of Dresden and Saxony, and it will be posted to you and today, but for the virtual reasons, we have only a digital thank you for you.
Thank you so much. That's very kind. And thank you again for the invitation. Really appreciate it.
Thank you so much for giving us the keynote lecture today.